Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Irfan Syafiq bin Muhammad Rosli. I represent my group to explain about the introduction of solar power generation. What is solar power generation? Solar power is the conversion of energy from sunlight into electricity, either directly using PV or indirectly using concentrated solar power or a combination. Concentrated solar power system use lens or mirrors that solar tracking system to focus a large area of sunlight into a small beam. Photovoltaic cell convert light into an electric current using the photovoltaic effect. Photovoltaic are initially used as a source of electricity for small and medium-sized application, from the calculator powered by a single solar cell to remote homes powered by an off-grid rooftop PV system. As the cost of solar electricity has fallen, the number of grid-connected solar PV system has grown into the millions and gigawatt scale. Photovoltaic power stations are being built. Solar PV is rapidly becoming an inexpensive, low-carbon technology to harness renewable energy from the sun. Passive homes are designed to welcome in the sun through south-facing windows and then retain the warmth through concrete, bricks, tile and other materials that store heat. Some solar power homes generate more than enough electricity, allowing the homeowner to sell excess power back to the grid. Batteries are also an economically attractive way to store excess solar energy so that it can be used at night. Scientists are hard at work on new advances that blend form and function, such as solar skylight and roof shingles. Then we move to the theory. How is solar energy used to generate electricity? A photovoltaic or PV system is used to convert the solar or light energy into the electrical energy. The basic component of PV system is known as solar cell. The single solar cell have a capacity of producing about 0.5 volt of electricity. The solar panel or solar module is a combination of several solar cells that connect in series to generate usable voltage. The solar panel voltage can be increased by increasing the number of solar cells. For example, 30 solar cells connect in series will produce the output 50 volt. A combination of solar panels that connect together is called solar array that can be used to achieve current and voltage. How does solar cell work? By generating of electricity on an enclosure is known as PV effect. This effect is used by solar cell to produce electricity. Solar layer is made by semiconductors such as silicon that contain 3 layers, which is the second layer is called N-type layer, which is contain high concentrated of electrons. Then bottom layer is P-type layer, also contain high concentration of hole. When P-type and N-type semiconductor is joined, it forms PN junction. The electron of N-type try to reach P regions that create the negative charge layer. It also happens to P-type layer, which is want to enter the N-type regions that create positive charge that called as depletion region. Sunlight penetrate the dot layer that easily to reach depletion region. Due to depletion region, it contains neutral atom, which is the atom we destroy when the photon enter the depletion layer. The knock of the electron from the neutral atom leaving behind the hole and producing free charge carries. Then the electron move toward the n-type layer and the hole move toward the p-type layer due to electric field present in the depletion region. Depletion region that connect the electronic circuit. The electric flow through it generating electricity to electrical device like lamp, fan and other.
Assalamualaikum and hello. My name is Mohamad bin Shahar. Metric card number 2010911067. I will continue the presentation with the mathematical model of solar power generation. A photovoltaic system is designed to supply usable solar power by means of photovoltaics. It entails arrangement of several components, including solar panels, which absorbs and converts sunlight into electricity, a solar inverter, which changes the electric current from DC to AC, and other electric accessories like cable to set up a working system. Globally, a formula E equals to A times R times H times PR is followed to estimate the electricity generated in output of a photovoltaic system, where E is energy in kilowatt hour, A is total area of the panel in square meter, R is the yield of the solar panel given by the ratio electrical power in kilowatt peak of one solar panel divided by the area of one panel. PR is equal to performance ratio. The PR or performance ratio is constant for losses, range between 0.5 and 0.9, and the default value is 0.75. For example, the solar panel yield of PV module of 250 watt peak with an area of 1.6 square meter is 15.6%. It is worth mentioning that this nominal ratio is given for STC, that stands for Standard Test Condition. For a photovoltaic solar panel or module is defined as 100,000 watt per square meter of full solar noon sunshine. Irradiance when the panel and cells are at standard ambient temperature of 25 degrees Celsius with a sea level air mass or AM of 1.5. The unit of the nominal power of the photovoltaic panel in these conditions is called watt peak. To compute H or annual average solar radiation on tilted panels, one must determine the annual worldwide incidence solar radiation on PV panels at a certain inclination, slope, tilt, and orientation or azimuth. For example, at Dhaka station in Bangladesh, it is found that the optimal tilt angle of 20.833 degrees results in an average solar irradiance value of 5.337 kilowatt hour per square meter day, whereas the average solar irradiance on a flat surface is 4.952 kilowatt hour per square meter day. Therefore, for the entire year, the average gain on the ideal tilt angle in relation to a horizontal surface is 8.71%, as it provides performance of the system regardless of the orientation or inclination of the panel. PR gauges the quality of a photovoltaic installation. Performance ratio of a plant for a period of time is energy measured in kilowatt hour per irradiance on the panel in kilowatt hour per irradiance on the panel in kilowatt hour per square meter times active area of PV module in meter square. It encompasses all losses regardless of system size, tech use, or location. That is all from me for the mathematical model of solar power generation. Thank you.
Hello and Assalamualaikum to Dr. Hanisa. My name is Amir Jafri. I with my crewmate here will represent to you solar. World electricity demand is expected to grow by more than 50% by 2030, mostly in developing and emerging economies. To meet this demand while also realizing global development, government enables solar to achieve its full potential. Solar PV is on course to account for 60% of global renewable power growth in 2022, followed by wind and hydropower. Solar photovoltaics are the fastest growing electricity source. This massive renewable energy produces almost 3% of the world electricity and being predicted will increase as much as 13% of world population power needs. The top installer of PV were China and United States. China has been top ranking in the world in solar power and the world largest market for both PV and solar thermal energy. Solar PV power generation reached a record 179 terawatt in 2021. This value is large enough to express annual electricity generation for the entire country. As Malaysia transforms into a high-income nation, the national development strategy must be in line with the megatrends of the world. Just about every roof at Goodyear Malaysia facility is lined with a solar panel. Solar panel will be installed on the roof of government buildings. The government also creating Malaysia's first green energy island at Pulau Redang and Pulau Perhentian, which will supply consumer 24/7 electricity supply by 2025. As you can see, the best exported PV power potential in Malaysia are located in Sabah. Solar projects at Kudat and Kuna are keep on expanding at a huge scale. Southeast Asia has large renewable energy reserves. This abundant energy can meet the energy needs for decades to hundreds of years to come. Southeast Asia major renewable energy are solar energy, wind energy, biomass, and hydropower. It's clearly seen that the most renewable technology preference in Malaysia are solar. Solar panels have high energy efficiency, which defined as the amount of energy potential that become electricity compared to the biomass energy, which is much lower. Solar energy is also the cleanest energy. The primary source of our country renewable energy depending on solar. So, why is solar energy is one of the best source of electricity today? Solar will continue to become more popular because it provides the greater energy independence. Panels are getting cheaper. It has a great potential and innovation. It products the least environmental treat compared to the other renewable energy. It adds value to homes that have a solar panel. Solar energy system batteries are constantly being developed to produce greater efficiency. Today, solar panel energy efficiency is higher than ever. Thank you.
Hi, my name is Nazrul Hamizan and I will discuss about advantages and disadvantages for solar power generation. The first advantages is energy production is clean. The method of converting solar energy does not cause pollution. The process does not involve drilling, blasting, burning, and other activities associated with non-renewable energy source. Hence, we may see the process of producing the solar energy is clean. Solar energy generation does not cause air, water, land, or noise pollution. There is no risk when installing solar panel on houses or schools. These panels are regarded very safe for usage anywhere. So for the second one, the solar panel have low maintenance and durable. The machinery required to produce solar energy has no moving parts. They are strong because they are hardly ever experience wear and tear. The only potential maintenance issue with solar panel is the possible need to clear debris that could preventing the PV cell from being exposed to sunlight. To prevent this, the solar panel are coated with substances to giving it a high level of durability and installed at a slope to allow debris to slide off. Thus, minimum maintenance is required. Additional, solar panel were also a long-term investment because they should have a lifespan about 25 to 30 years. So for the advantages, the first advantages is the location and weather dependent. Some states and regions in the world receive least amount of sunlight than others. The production of solar panel is also decreased by cloudy conditions since they require sunlight to generate electricity. Therefore, solar might not be a practical option for certain region or country. It is also no guarantee that even at a location with superior solar exposure, there will be enough sunshine to sufficiently power user building. Even after the initial expense of installing solar panels, some users might still need to pay extra to fill up their power. The second one is solar panels are not green. While solar energy may be green, the production of solar panel is not. The photovoltaic cells used in converting sunlight into energy contain hazardous material. They include hydrochloric acid, sulfuric acid, nitric acid, acetone, and hydrogen fluoride. These materials are not handled and disposed of properly. They pose significant pollution risks. Factory workers are also at risk of inhaling poisonous fumes during solar power production. So, while solar energy production does not contribute to carbon dioxide and other greenhouse gas emissions, the creation of each solar panel leaves a carbon footprint. So, for the third one is property monopoly. We need a lot of land space and more solar panels to generate substantial amount of solar energy. While some homeowners may get by using solar panel on their roof, this option is not sustainable for larger solar projects. Town and communities looking to generate shared capacity and achieve energy independence typically have to find dedicated land space. The problem is that the solar panels monopolize land space. There is a low probability that a solar farm can share land spaces with other needs, such as agriculture. Installing solar panels on a large field could result in the degradation of land and loss of habitat for some animals. There are also concerns about impact of increased solar activity on the thermal balance of specific area. The increase of thermal activity could pose a risk to plants and animals which may not survive in artificially altered environment. The last one is high initial cost. However, this type of solar-based power generation system may also have some deficiency which arise from the system. As for example, solar generation have high initial costs in order to develop practical and convenient system. It is due to expensive costs required for the energy storage like battery that used to store energy when there is excess electricity and can be used the excess power at night or at a time when generation of electricity is low. Okay, so for our assignment conclusion, without a doubt, solar energy is an important renewable energy source. It is limitless and accessible to both large and small groups. Despite its advantages, we should not forget that solar energy has certain environmental issues. Because of its feasibility, experts throughout the world have looking for innovative ways to enhance solar energy generation and decrease its negative effect. While solar energy is now significant improvement over non-renewable source, it is still far from being completely environmental beneficial. Currently, the battery storage system option for storing the solar energy is as electrical energy are very expensive and quite impractical for system to use the electricity asynchronously. As for now, it only considered effective for direct power generation to the grid where storage capacity is not required. Thank you.